Very well, to continue with our training, we are going to touch on a very interesting topic in inverter technology, which is the bidirectional communication signal between indoor and outdoor units. It is a very interesting topic because, in addition to being damaged quite a bit, it is a complex topic for most technicians. It is difficult for them to understand it really, but we are going to give explanations as always simple, clear and sharp so that you can perfectly understand how these communication signal circuits work. As a sample and to be able to explain it and understand it, we have an indoor and an outdoor plaque with its reactor, which it needs to be able to turn on and energize. Here we have the electrical interconnection, line, neutral, and signal. They are the only three cables we have. We don't have the earth placed so as not to confuse us, nor do we even have the display placed. To understand how this works, first of all we are going to do some measurements and then we are going to be explaining in graphs how it works, what it does to be able to communicate from one side to the other. The first thing you will do, when repairing or checking inverter air conditioners, when you have a communication error, is to energize the indoor or outdoor unit, the one that is energized, and to be doing some measurements on the communication cable. How do we do it? With a simple multimeter. We place the multimeter in direct current and measure between the N cable and the S cable, and we will observe what appears on the screen. Preferably, place the black cable in N and the red cable in S or C of communication. Well, now we don't have any voltage. It would be perfect. Let's start the team. Now yes, we have to find the voltages that interest us. Observe please here the number I have on the multimeter, 15 volts, 4, 22, 15. 2, 22, 15. 4, 22, 15. 2, 20, 15. 4, 22, 15. That data is important. That variation is important. Do you notice that there is an intermediate voltage? 15 goes down and goes up. It goes to 2, it goes to 22, to 2 and to 22, and goes back to 15. That's how an indoor unit communicates with an outdoor unit. When the voltage drops, one communicates with the other, and when the voltage rises, the other communicates with the first. That's the way they have to communicate with each other. That's exactly what we're going to see with the oscilloscope. There are units that communicate up to 50 volts, so we have to activate 10x. Tell the multimeter that we're going to use 10x and place the negative test lead on N and the positive lead, or the positive test tip on S. We're going to zoom out so we can see what's on the screen. We'll increase the voltage a bit so that 40 volts appear on the screen. Okay, there we have the same thing we saw with the multimeter. It stays at 15, goes down to almost 0, to 22, 24, and goes back to 15, 0, 22, 24, 15, 0, 24, 15. And it's about every 3 or 4 seconds that the communication takes place. Approximately every 3 or 4 seconds, the units communicate to inform each other what is happening in one and the other. Well, that's how they communicate. In fact, if the communication fails, the voltage will not only go up or only go down, which would indicate a failure in one of the two units. And if this variation does not occur directly, it may be a problem with the processor, which is responsible for generating these pulses. What you are seeing here is not arbitrary. Well, yes, it is arbitrary because the manufacturer did it in his own way, but they are not meaningless pulses. The units understand each other, and there are many intermediate pulses that, if you look closely, change over time. That's how they communicate. But how does this communication take place? What parts are involved? What components do we find on the boards that help one communicate with the other? Well, we'll see that next, in the next video. Please leave a comment if you have any questions.